Hello class, Dr. Banks here. So let's take a look at these sequences and then find their respective Z transforms, okay? So let's go to I. So I, we have x of what? N is equals to 2 minus 1, 3, 2, 0, 1, okay? And the arrow is on this one here, N is equals to what? 0. So 0, 1, 2, 3, 4, 5. So here n is equals to what? 5. Okay, so here you see that the signal is going this way. It's going to the right. It's going to the right. So it is called right-sided sequence. Okay, the sequence is going to the right. So it's called right-sided what? Sequence. It's going to this place. Okay, so it's called what? Right-sided sequence. Okay, right-sided sequence. So either you say right-sided sequence or you can also say causal sequence. Causal sequence. Causal. Okay. Because you see, n equals to 0 here, the rest are going this way, going to the right, is right-sided sequence. Okay. So now let's just find the respective Z transform for this word sequence. Okay. So here I can see that x of n is equals to what? Summation n is equals to infinity minus infinity x of what? Sorry, x of z. X of what? Z. Okay. X of what? N into z minus what? N. Okay. So now this one is equals to what? Here infinity. Here not infinity. Okay. It's what? 1, 2, 3, 4. It's 0, 1, 2, 3, 4, 5. So here is what? 5. Here is what? 5. And here n is equals to what? 0. And then here I'm going to have x of what? N into z minus what? N. Okay. So this is what I'm going to have. So now here what I can say is that the summation, okay, here 5 n is equals to 0, x of what? N into z minus what? N is equals to, if I'm going to expand this summation or expand this summation, okay, what am I going to actually have? Okay, I'm actually going to have, it's going to be equals to x of what? 0, okay, and then plus x of what? 1 into z exponent minus 1 plus x of what? 2 into z exponent minus what? 2 plus x of z into what? 3 into z exponent what? Minus what? 3, okay, plus x of z into what? 4 into z exponent minus what? 4 plus, so it was what? 0, 1, 2, 3, 4, 5. X of z of what? 5 into what? Z exponent minus what? 5. Okay, z exponent minus what? 5. Okay, so these are what I'm going to actually have with respect to this particular sequence. Okay, so now if I have this, then what I can say is that x of what? Z is equals to what? Here x of 0. What is x of 0? X of 0 is 2. Okay, 2. What is x of 1? X of 1 is what? 1. So minus 1. Minus 1 into z minus what? 1. Okay, plus x of 2 is what? 3 into z exponent minus what? 2. X of what? 3 is what? X of 3 is 2. 2 into what? Z exponent minus what? 3. Plus x of 4 is what? 0. Okay, x of 4 is 0. And then x of 5 is what? 1. So plus what? Z exponent minus what? 5. So this one, what I can say is that it is equals to what? 2 minus what? 1 over what? Z plus 3 over z what? Squared plus 2 over what? Z what? Cube plus 1 over z what? Exponent 5. Okay. So now here, if I divide this one by 0, it will go to infinity. If I divide by 0, it will go to infinity. Divide by 0, it will go to infinity. If I divide by 0, it will also go to what? Infinity. So now, this is the what? Z transform. This is the Z transform, all right, okay? But for my ROC, because it's going to infinity, I will say that the ROC, okay, is the what? Entire Z plane. Is the entire what? Z plane. Except what? Except Z equals what? 0. Alright. So that becomes my what? My ROC. Okay. So now we can just go on to the next question. Alright, let's go to the next question. So the next question is what? II. You see that if you look at II, it is what? All the signals are going to the left. So it's what? A left-sided what? Signal. It's a left-sided signal. Left-sided signals are called what? Anticausal signal. They are called anticausal signal. So II. Okay, so II. So x of what? N is equals to what? X of n is equals to 3, 2. Okay, minus 1, minus 4, okay, and then 1. Okay, so now here, x of what? Z is equals to infinity, okay, infinity here, minus infinity here, okay, x of what? X of n into z minus what? N, which is equals to summation, okay. Here, my arrow is on this one. This is my arrow. My arrow is on this one. That means that n is equals to 0 starting from here. So you see that all the signals are, all the sequence is going this way. So it's what? A left-sided what? Sequence. So here, n is equals to, here, n is equals to 0. And then 0, 1, 2, 3, 4. Okay. 0 to what? 4. Alright, 0 to 4. Okay. So here, sorry, I have to write it again, okay? Because basically, this is minus 1, this is 0, minus 1, minus 2, minus 3, minus 4. Okay, so what I can say is that here is what? Minus 4, and is equals to what? Minus 4. And then it's going to what? It's going to 0. Okay, because 0 is bigger than what? Minus 4. Into x of what? N into z minus what? N. So this becomes my what? My formula. Okay, to deal with this particular sequence. So now I said that because it's going to the left, it is called what? It's called left-sided what? Sequence. Okay, left-sided sequence, or what? Anticausal sequence. Okay, or anticausal what? Sequence. Okay. Okay, so now that's how you can deal with this one. And then after you have dealt with this one in this way, okay, we can now find our what? Our Z transform. Okay, so our Z transform is actually equals to what? What can we say here? Our Z transform is going to be x of what? 0. X of 0. Or we can start from this place and come here because if you check our equations from n is equals to minus 4 to what? 0. So let's start from minus what? 4. X of what? Minus 4. So minus 4. So the exponent here will be what? Minus 4 minus 4, which will be what? Plus 4. So I'll just put plus 4 here. Plus x of what? Minus 3. So it will be what? Minus 3 minus 3, which will be what? 3. So plus x of what? Minus 2 into z squared plus x of what? Minus 1 into what? Z plus what? Plus x of what? 0. Okay, so basically this is going to be our sequence, okay, into the Z transform. So here, what we're going to have is x of minus 4. What do I have there? I have 3. So Z exponent what? 4. Plus what? Here I have what? 2 into Z exponent what? 3. Here I have what? Minus what? 1 into z exponent what? 2. Here I have what? Minus what? 4 into z exponent what? 1. And then I have what? Plus 1. Okay, so this is my what? My x of what? Z. Okay, so this is my x of z. So now, if you check here, if I put z exponent infinity to go to infinity, z exponent infinity to go to what? Infinity. Z exponent infinity go to what? Infinity. Z exponent infinity go to what? Infinity. So this is my z transform, all right. But my ROC now becomes what? The entire z plane. Okay, except what? Except z equals infinity. Okay. All right. So now let's go to our next question. Okay. Let's go to our next question. So in the next question, we're going to have I. So I. What do we have in I? So I, we are going to actually have x of n to be equals to, here we have 1, 2, minus 1, 2 and 3. Okay, 2 and 3. And then where is our arrow? Our arrow is on minus 1. So here this n is equals to 0. So here it's neither left-sided nor right-sided, because some of the sequences on our right, others are also on our left. So we cannot say it's right-sided or left-sided. Okay. But what we can actually say is that it's a two-sided, because some are on the left, some are on the right. So it's a what? A two-sided what? Sequence. Okay, a two-sided sequence. So let's find the z transform for this. So z transform for this one will be what? This one is n is equal to what? This minus 2, minus 1, 0, 1, 2. Okay, so what I can have is, I can have x of what? Minus 1 into z. So minus 1. So here exponent, here is going to be what? Minus 1, minus 2, okay, which will be what? 2, okay, plus what? X of what? Minus 2, so here to what? Z minus 2, minus 1, to what? 1, plus what? Here, sorry, it will be, because here is minus, okay, so no, let me just maintain it. X of what? Minus 1, okay, plus this one. Okay, so here's x exponent what? 0. Okay, any number exponent 0 is 1. So, and then we have what? X of what? 1. Sorry. This place is x of what? 0. Alright. So let me put 0 here. Sorry. Okay, so x of what? 1 into z exponent minus 1 plus x of what? 2. S of 2 into z exponent minus what? 2. Okay, so that's going to be our sequence. So here x of z is equals to what? X of minus 1 is what? 1. So it's what? S squared. Plus x of minus 2 is what? 2. So 2 into what? Z. X of 0 is what? Minus 1. So minus what? 1. Okay, plus x of 1 is what? 2. So plus 2z minus what? 1. Plus x of 2 is what? 3. So 3 into z minus what? 2. So my z transform is going to be what? S squared plus what? 2z, okay, minus 1 plus 2 over what? Z plus 3 over what? Z squared. Okay, so this is going to be my transform. Then what will be my ROC? Okay, so what will be my ROC? So now my ROC is going to be what? This place, okay, this place. If z exponent infinity will go to infinity, z exponent 1 will go to infinity, 2 divided by 0 will go to infinity, 3 divided by 0 will go to what? Infinity. Okay, so is the what? The entire z plane. okay, except z equals what? 0 and what? Infinity. Okay, so that is our third solution. That will be our third what? Solution. Okay, all right. So now let's go to the next solution, which is solution number what? 4. Okay, so number 4, our sequence is like this. Okay, x of what? N is equals to x of n is equals to here 1, 2, 0, minus 4, okay, 3, 2, okay, 1, 6, 5. Okay, so these are sequence, and then our arrow is on the 3 here, n is equals to what? 0. Okay, so our x of what? Z is equals to what? Summation infinity, n is equals to minus what? Infinity. This is a two-sided sequence, because some of the sequence is on the right to the 0 and others are also on the left to the 0. So it's a two-sided sequence. So x of what? N into z exponent minus n. Okay, which is actually equals to what? Z here, this place is 0, minus 1, minus 2, minus 3, minus 4. Okay, I'm starting from what? Minus 4. 1, 2, 3, 4. To what? To 4. Okay, x of what? N to z minus what? N. Okay, so this is a formula that we're going to actually use. Okay, now let's just be fast with it. Okay, so now our x of what? Z is actually going to be equals to this. Okay, it's going to be equals to this. X of minus what? 4. Okay, into z exponent what? 4. Because minus 4 will be what? 4. Okay, plus what? X of minus what? 3. Into z exponent what? Minus 3. Okay, plus x of what? Minus 2. Into z exponent, sorry, here to be positive 3, because minus 3. Okay, minus 3 to positive 3. Z exponent what? 2. Okay, into what? Plus z of minus what? 1. Into what? Z of minus 1 into what? Z plus x of what? 0 into z exponent what? Sorry. Into z exponent what? 0. Okay. Plus, okay. Plus what? Plus x of what? 1 into z exponent minus 1 plus x of what? 2 into z exponent minus 2 plus x of what? 3 into z exponent minus what? 3 plus x of what? 4 into z exponent minus what? 4. Okay, so that will be our z transform. So let's quickly convert this one. If we convert this one, what are we going to get? We're going to have x of what? Z is equals to what? What is x? X of minus what? 4. X of minus 4 is what? 1. Exponent what? Z exponent 4. So it is what? Z exponent 4. Plus what is z of minus what? 3. Z of minus 3 is what? 2 into what? So 2 into z exponent what? 3. Okay, then x of what? Minus 2 is what? 0. X of minus 2 is what? 0. So we will not write the 0. Then x of minus 1 is what? Minus 1 is what? It's minus 4. Okay, it's minus 4. So I'll have what? Minus what? 4 into z exponent what? 1. Then x of what? 0 is what? 3. So plus what? 3. Then x of 1 is what? 2. So 2z exponent minus 1 plus what? X of what? Minus x of 2. X of 2 is what? 1. 1 exponent what? Z exponent minus 2. So minus 2. X of what? 3 is what? 6. So plus what? 6z exponent minus 3. Then x of 4 is what? 5. So it's what? Going to be what? 5z exponent minus what? 4. Okay, so this is going to be our sequence. So if I should rewrite this one, then my x of what? Z is going to be equal to what? Z x exponent 4 plus what? 2z exponent 3 minus what? 4z, okay, plus what? 3, okay, plus 2 over z, okay, plus what? 1 over what? Z, okay, Z squared plus 6 over what? Z cubed plus 5 over Z exponent what? 4. So this is my Z transform. What will be my ROC? My ROC, you see here, if it is exponent, it's Z exponent 4, okay, Z exponent 4. What happens is that if Z is infinity, then everything is going to run into what? Infinity, okay? And then here, if Z exponent 3, if Z is infinity, it runs to what? Infinity. Here, same thing here, 2 over Z. If Z is what? 0, it will run to infinity. If 1 over Z square, if Z is what? 0, it will run to what? Infinity. So the entire Z plane, okay, except Z equals 0 and what? And infinity. So that will be the end of question 4 also. So let's just go to the next one, okay? Let's just go to the next one, all right? Okay, so our next question is question number 5. So question 5 is being, okay, we have x of what? N is equals to what? U of what? N minus what? Un minus what? 3. Okay, so this is a signal. Now, let's plot the signal and see which particular values we have to take. Okay, so now, if I'm plotting the signals, okay, this sequence, okay, U of N, where is U of N? U of N is positive, okay, so that means that it must go this way, all right? Here, N minus 3. N minus 3 means that N is equals to what? Here is 0. U of N means that N is equals to what? 0. Okay, here is N, okay? Okay, so here is what? U of what? N. Okay, here, basically it will be what? 1 here. So here, N minus 3 means N is equals to what? 3. So let's say that this place is what? 3. And you see that here is what? Minus, meaning that the signal is going to the what? To the reversal direction, to the opposite what? Direction. So N is equals to what? N minus 3 means that N is equals to 3. So this is N is equals to what? 3. And the signal is going to go what? This way. Okay, so what is our main signal? Our main signal is therefore going to be here. It's therefore going to be here. Okay, so please let me write here. Here is what? Minus U N minus what? 3. This is this signal, and this is this what? Signal. So our main signal is the what? Is the point of intersection. Okay, which is this place. Okay, which is this particular place. Okay, so now this particular what? Place. Okay, here is 0, here is what? 3. So which values can I have here? I can have x is equals to what? 0, okay, and I can have x is equals to what? 1, 2, and then 3. So I can have what? 1 here, 2 here. So basically this becomes my signal of what? Interest. So now what I can say is that x of n is equals to what? 1. Let's see, basically it has a value of what? 1. So 1, 1, what? 1. Okay, basically that is what the signal implies. Okay, so here I can say that this place is n is equals to what? 0. Okay, and then it's going to this particular place. Okay, so now here, in this case, what is going to be my x of what? Z. Okay, my x of what? Z. Okay, so now my x of Z, which is the Fourier transform in this case, is going to be what? X of what? Sorry, x of what? Z. Okay, my Fourier transform is going to be summation here. N is equals to what? 0. And here 0, 1, 2, 3. And here is what? 3. Okay, so here x of what? N to what? Z minus what? N. Okay, so x of what? Z is actually equals to what? So x of Z is going to be here x of what? 0 plus x of what? 1 into z exponent minus 1 plus x of what? 2 into z exponent minus 2 plus x of what? 3 into z exponent minus what? 3. So now here my x of z is going to be equal to what? X of 0 is 1 plus what is x of 1 is also plus what? 1. 1 into what? Z exponent minus what? 1. Okay, plus what? Here, x of 2 is what? 1 into z exponent what? Minus 2. So z exponent minus 2. Here, x of 3 is what? 1 into z exponent what? Minus 3. So z exponent minus what? 3. So now here, my x of what? Z is equals to 1 plus 1 over z plus 1 over z squared plus 1 over z what? Q. Okay, so this is my sequence. Hey, this is my Laplace what? Transform. This is my Laplace transform. Now, let me see. What is going to be my what? My ROC. Okay, so now for the ROC, what you can actually see in this sequence is that if I divide this one by what? 0 to go to infinity, by 0 to go to infinity, by 0 to go to what? Infinity. Because what? It's a right-sided what? Sequence. So ROC, okay, is that, okay, the ROC, okay, is the what? Entire Z-plane. Okay, entire Z plane except Z equals what? 0. Okay, so that will be the end of this particular question. Thank you so much and see you in the next class.